Lesson 7, Linear Relations. A linear relation is a relation that is a straight line graph. So we're going to graph this to see if it's a straight line. So we have our y and our x-axis. And we're going to do the number of toppings on the bottom, because that's going to be our independent. And our dependent is the cost. So we're going to plot our points. So our 0 extra toppings is $12. So let's go, every 2 spaces is a 1 on the bottom. So 1, 2, 3, 4, 5, 6. And up on the top, let's take a little bit out of the graph and make every one worth 50 cents. So this will be 12, 12.50, 13, 13.50, 14, 14.50, 15, 15.50, 16. So we're going to plot 0 is $12. 1 is $12.75. 2 is $13.50. 3 is $14.25. 4 is $15. And 5 is $15.75. If you look at these lines, you can see that it makes a line between the dots. So it will be a linear relation. So we're going to check to see how we figure that out with just our numbers. So we're going to check the increase between the values. So from 12 to 12.75, that's 75 cents. From 12.75 to 13.50, again, 75 cents. 13.50 to 14.25, 75 cents. 14.25 to $15, 75 cents. And you guessed it, 15 to 15.75 is 75 cents. So the change in our y values, so that's our dependent, these are our y values, goes up by 75 cents. So adds 0.75. When we go from 0 to 1, this is 1, 2, 3, 4, 5. They all go up by 1. So the change in x values is 1. So that means that because it's consistent for both the y's and the x's, it's a linear relation or a linear function. So when you have an equation of a function, you need to check to see if it's linear. You're going to plug in points. And the points that I would choose are -2, -1, 0, 1, and 2. And making a table of values with an x and a y column is the most organized way to do this possible. So you need to do this. So we're going to plug in our x values. So -3 times -2 plus 25. Type that into your calculator. You should get 31. -3 times -1 plus 25. Type that into your calculator and you should get 28. -3 times 0 plus 25. Shouldn't have to put that into your calculator at all, because 0 plus 25 is 25. -3 times 1 plus 25 is the same as 25 minus 3, which is 22. And -3 times 2 plus 25, you should get 19. So now we're going to check to see if we're going up by consistent amounts in here. So to get from 31 to 28, you're going to subtract 3. To get from 28 to 25, you subtract 3. 25 to 22, minus 3. And 22 to 19, minus 3. Because these are all going up by ones, it's consistent for both sides. This is a linear relation. Now let us try the next one. So we have, try again, -2, -1, 0, 1, and 2. Plug it into our equation. So 2 times -2 squared plus 5. You should get 13. 2 times -1 squared plus 5. You should get 7. 2 times 0 plus 5 is 5. 2 times 1 squared plus 5 should be 7. And 2 times -2 or +2 squared plus 5 will be 13. So as you can see, when you go from 13 to 7, you're going to subtract 6. From 7 to 5, you're subtracting 2. So this isn't the same already. So you know this isn't going to be linear. A quick way to notice this too is if you have a squared number, it will never be a line. It's never linear. Example 3. For a service call, an electrician charges $75 flat rate, plus $50 for each hour he works. The total cost for a service is related to the time. So let's make a chart. So this is the hours and the cost. So for hour 1, you're going to pay $75 plus $50. I guess we could do hour 0 first. So flat rate, 0 hours, you get $75. For 1 hour, it's 75 plus 50, which is 125. For 2 hours, you're going to do 75 plus 2 times 50, because he's there for 2 hours, so it'll be 175. And if you check between these numbers, you're going to go plus 50 for each one. So this will be a linear function.